Okay, hi everyone. So continuing with our topic on displays, continuing with our subtopic on display design principles. The last couple of sub lectures here covered the 13 display design principles I really want you to know well, but then there's a couple of other ones from other sources I wanted to make sure I get in there too. So these are the others. This is 4.2.3, right? Other display design criteria. Okay, so 1472H, the military standard, which we are now becoming increasingly familiar with, and we're going to be using more and more, in our classes coming up here, topics coming up. It has its own section on criteria for visual displays. I think it also has one for auditory displays, if I remember correctly. But for the most part, this is where I wanted to point you. So section 5.2, it starts on page 106. It's about 22 pages of this style of criteria design guidance. Also, now there's another, I don't have it on Canvas, but we have this military handbook, which is a bit older, but includes its own set of criteria. And these are pretty basic sorts of criteria here. If you are designing for an environment where it's really important that the right message gets across and not much more. Display only essential information as accurately as required, or I should say even as precisely as required. Don't give me, 8 digits of significant digits if I don't need that. Present info in a way so that if there's a failure, this becomes obvious. That's something you definitely would want to detect. So the display should make that pretty clear. Give us usable information, not just, oh, it's nice to know this, like this is towards the task we're working on. Arrange them in a way. I'm going to talk a little more about display arrangement here, but in the ability to locate a key display, especially under stress, very important. Group those displays according to their common function or their sequence. This is a good example of applying one of my favorite, the proximity compatibility principle from 4.2.2. You can check that out. Displays should be properly illuminated, color coded, and labeled. You're going to hear more on that here coming up. The viewing distance. Now the maximum and the minimum viewing distance is a little confusing to me, because it's not like you only want people to view within this range. But if it's if there is a display that is used with a control, you've got a maximum distance that they should be away, and the minimum distance to be viewed is about preferably not less than 20. So you don't need to be too close to view this. We know about dark adaptation, so consider that in your design of displays as well. And then finally, if the display fails, that should not cause the whole system to go down. It's just the data that you maybe need to appropriately do the human task there. But don't have, if the display fails, it shouldn't lead to other aspects of the system failing. All right, so again, those come from the Military Handbook 759C 5.2.1. I'll see if I can find that, and I'll make sure that's on Canvas too. Okay, good. So, and this comes back from the textbook. We're going back to the text for these. So on that topic of where do I put the display? So we haven't really talked much about that so far. Humans have what we call the primary visual area. The best example I have of this is when we're driving. And if you imagine you're sitting in a car right now and looking down the road, where your eyes are resting, we call this the primary visual area. It's usually a little bit lower than the horizon. So if you think about, well, where are things most interesting to humans in a general sense? They're towards the horizon in front of us, but not quite to the horizon. We're below the horizon, the things that we may encounter as we move forward here. Other examples here, if you're sitting at a desk where I'm sitting right now, my computer screen, my laptop screen is right in my primary visual area. This is also a good example. I mean, we've got two humans that have to be accommodated here. So we've got, the primary visual angle for one is not going to be the same for the other, but we've got these key displays at an elevation that's right at the right level for the resting sort of position of the human eye. So these are the most precious commodities, or the most precious real estate, so to speak, for displays. So you want only the displays that you need to look at the most often, or which have the most important display data on them. So frequent use, most important data. These are the two reasons why you would prioritize that space for certain displays over others. The layout of these displays, so not just where they are, but how they're configured, where relative to each other. So if you want to think about, again, the proximity compatibility principle, how often is one display element required to be used with another display element? And a lot of times, the best way to do this is to put them close together. And so, or to have them in an arrangement where related displays can be found pretty easily. And so, consistency is a big part of this. That was another of the 13 display design principles. And I've got an example here of aircraft, the key displays. They actually call this the six-pack, or they can call it that. And the key displays that you'd need to fly an aircraft, this is the older sort of look to it. And what you see here is a very common arrangement where airspeed, altitude, altimeter, and then right below it, the heading in this sort of T shape. That's how we find those four key pieces of information, that I need for flying an aircraft. And note that, here on the right, those displays would be very regularly in this configuration, in this T block configuration in my six-pack. And so then when we transition from these steam gauge, these more mechanical displays to what we call a glass cockpit, so it's digitizing these displays, you'll note that we follow the same arrangement there, right? So airspeed on the left, altimeter on the right, attitude of the aircraft, that's the attitude, what's the orientation relative to the horizon. All right, so then this is again key, especially under duress, under stress. I got to find this key piece of information. Don't make me go looking for it. Rely on the human need for consistency, especially under those contexts. Okay. All right, so now we have a couple of sort of special cases here as we're talking about how to convey information visually. So pictures and graphical icons have their own sets of kind of criteria here. You can write very eloquently an explanation of something somebody should do or not do. But like they say, a picture is worth 1,000 words. If you can encode that meaning into an icon, into a graphical representation, now I don't have to write everything it means to like something. I just recognize this icon and all of the ideas that it represents. I recognize this shape and all the potential issues it might represent, right? So I don't have to have a whole bunch of verbiage to explain this. Also, icons, pictures are international language. So we don't need to worry about, what's our population in terms of what's their primary language. Okay. We need to consider the contrast and the size of graphical icons, just like we do text. We have to consider the conditions under which they'll be viewed, and especially if we're using color. So we remember that the hue of the icon is viewed against the background, and this is affected by the illumination in that space. If it's a sticker or a label on a static surface, then now we have to think about reflectivity. We have to think about, do we have photopic, scotopic vision going on, for example. So yeah, I've got to consider all those things. Discriminability, being able to distinguish one graphical representation from another. Redundancy is a good way to do that. I've redundantly encoded yes or no, or positive or negative response in these two icons here. So I've got different colors, different shapes, right? Avoid negative labels if possible. This is a fun sort of like aside here. So people in general, they don't give enough attention to negatives. Okay, so the word no or not, or they see do this, not do not do this. So it's an extra word they'd have to read. It's a logical inversion that their brain has to make, and these are things that are not always trivial when people are trying to make split-second decisions. They're trying to look and gain information and act on it right away, like stopping, at a stop sign. So this is obviously a joke. Don't stop, and it's green. At least green helps. But the don't might be seen. It's just not processed deeply, as deeply as some of the other more keywords here. Okay, so avoiding those negative labels is great. Don't tell people what not to do. Tell people what they should be doing if you have the option, right? So people generally assume the positive message. Inverting it logically requires an additional step, and they could just miss that part of the message. So I've got some examples here where you can think, okay, those might confuse me. I may have to stop and think for a minute, and maybe I don't have time to stop and think. If depending on what I'm doing here. Stop. Wait, do not stand here. Oh. All right. This is an anti-no bully Zoom. So because only bullies are allowed here. All right. Now watch this. So here's why it's important, because if you're in a burning building, you're hoping to get out, and these are what you see. Take a minute and look at each of these and see if you can find the way out. So it's not through the bathroom door there, but you'll notice, I've got a lot of red, I've got a lot of capital letters, I've got a lot of the word exit, but not an exit is the opposite of exit. And so this doesn't, to me, and I think to humans in general, look all that different visually, and they mean the opposite. So this is potentially a problem. So again, the term exit, if you can avoid this is not an exit, it's going to be a much more effective sign. Okay. A couple more points here. So making sure that the icons are meaningful. We're not necessarily using any language at all. It's just imagery. So that imagery has to be clear enough on its own, right? And these are some examples. I think no bird, sorry. I don't know who's supposed to be following that. I don't know what's going on here. And I can guess that this is probably not like, hey, here's where you feed your children to the, I don't know, alligators or something. But these do have to be clear enough that they send the proper message. And one way to help with that is use verbal description labels, the word poison, the word research ideas, redundantly encoding what's going on with those icons there. And then finally, the location of where we put these things matters. This is a pretty funny picture here. I hope that people don't take this too literally and follow the right. But you should have the labels, the icons, the graphical depictions should be in a location where they will attract attention, they will be meaningful, and they can, change behavior, for example. So they need to be physically close and unambiguously associated with what they represent. I'd call this an ambiguous association with where you're supposed to be on the road. Again, the proximity compatibility principle is relevant here. All right, thanks everybody. Got one more subsection of this topic.